Hello everyone, welcome to Dr. Ravi's Academy. In today's class, you will be understanding how to draw the acceleration diagram for a slider crank mechanism. And let us look at the given problem. The data given is crank 150 mm long. Here BO is 150 mm long and connecting rod is 600, AB is 600 and the crank angle, the crank made with the line of stroke is 45 degrees and it is rotating in clockwise at a speed of 300 rpm. So this is what exactly the given data. So in this you will be solving this particular problem in 3 steps. Your step 1 is you have to draw the configuration diagram to the scale. Now you will be adapting a scale. Let me write the scale. Scale is 1:5 because the length is 600 mm. Connecting rod you cannot accommodate. For that you will be reducing it by or you are multiplying with 1/5 of 600 mm. So let us 150 divided by 5, that gives 30 mm. Draw a line at an angle 45 with the line of stroke and mark 30 mm. This is 30 mm long and this eye center, let us draw the line of stroke line, horizontal line with the help of compass. Here it is 600 divided by 5, that is 120. B eye center, let us draw a circular arc and locate the point A and join ABO, and it is rotating in clockwise direction. So here the scale is optional. You can give 1:5 or 1:6 also. Now let us proceed to velocity diagram. Your step 2 is velocity diagram. Here step 2 is velocity diagram. To draw the velocity diagram, you know very well. Here, crank is rotating at an angle at a speed of 300 rpm. Let us calculate the angular velocity of B with respect to fixed pole, that is BO, is 2 pi n by 60. Here it is 2 pi, n is given 300 by 60 and you have it is 5 and it is 10 pi and that is nothing but 31.4 radians per second. And the linear velocity of point B with respect to O is r omega. Here r is length, that is in meters, so it is 31.4 into omega is 31.4 and radius is the length of the crank in meters, that is 0.15. So this is velocity you are going to get, it is 4.7 meters per second. Velocity of B, this is the direction is known. As you know, the direction of the point B is perpendicular to the crank. This is the direction of BO. You know the direction and you know the magnitude also. So let us adapt a scale. Again, scale for velocity diagram is different and you are going to adapt a scale. Scale, it is 1 unit, that is 1 centimeter is equals to, let us take 1 meter per second, and this is your scale for the velocity diagram. And using this particular scale, and it becomes 4.7 centimeters and 47. So direction is known along this line. That means let us draw a line parallel to it, and the length is, this length is it is 4.7 units centimeters. So beginning point we will be calling it as a pole, that is O and G. Lowercase letters you will be using. The other end you are calling it as B. So this is the notation for the velocity image of crank. This is completely defined. You know the magnitude and you know the direction also. And as it rotates clockwise, the direction of the slider is a horizontal line. So you have the direction of velocity of a slider, that is A, with respect to fixed end, that is G. Direction you know, you can draw a horizontal line. And the velocity of, you want to locate point A, velocity of A with respect to B perpendicular to it. So with the help of mini drafter, keep your one scale along this and other scale, you can draw the scale, and this gives you point A, that is velocity of AG. And You got the velocity diagram, and you can calculate now the angular velocity of the connecting rod AB. So the velocity image is known. So measure this AB length. So this measurement, it gives you 3.4 units, that is centimeters, and velocity of it is A with respect to B is 3.4, it is meters per second, and the angular velocity you can calculate omega of AB is equals to, it is the velocity of AB by AB length, and AB is nothing but the length of the connecting rod. It is 3.4 by the length in meters, that is 600 mm is given, and you can take it as 0.6, and this gives you 5.7 radians per second. The angular velocity. One answer you got, that it is angular velocity, which he has asked in this particular problem, is asking you to calculate the angular velocity, that is omega of AB is how much, and alpha of AB is how much. These are the two things you have to calculate. Angular acceleration, angular velocity, you got the answer, and angular acceleration. To calculate this, you have to draw the acceleration diagram. To calculate the acceleration diagram, let us look at this. The radial component of acceleration of B with respect to O, you can calculate this value. I am denoting it by the direction, it is acceleration, radial component of acceleration of B with respect to O. It is V square by, that is VBO square by, that is R. R is nothing but VO. So this magnitude velocity of B with respect to O, you know that it is input velocity, that is 4.7, that is 4.7, that is velocity of B with respect to O, 4.7 square divided by BO. BO is the length of the crank, that is 0.15. So with this you can calculate the radial component of acceleration of BO. This comes to 148 meters per second square. This is one radial component of acceleration of the crank, and it is moving with the uniform angular velocity. Obviously, the tangential component of acceleration of this particular link will be 0. And the radial component of acceleration of AB, it is AB is, you can write down, it is velocity of AB square divided by AB length, and velocity already you have measured, velocity AB is 3.4, it is 3.4 whole square divided by AB length, that is length is 0.6, and this comes to, it is the value is 19.3 meters per second square. After knowing the radial component of these two links, let us proceed to the diagram. The direction of radial component of acceleration of B with respect to O is toward this. This is the direction. Let us draw a vector along this line. So beginning point is pole, you can denote it by O prime, and the other is G prime, and the end is B. So this is what is its B prime. So this is the acceleration image of the crank. Now you want to proceed to locate, B prime is located, you want to locate A prime. For that purpose, you see that it is the radial component, this is the direction. The radial component of acceleration of A with respect to B is in this direction. You can draw a line and denote it by the magnitude is, you know, already calculated 19.3, and locate X prime, that is intersection of your radial and tangential acceleration. After locating that, the now perpendicular to this, exactly perpendicular to this, you have, let us draw a line perpendicular to it, and this also let us draw dashed line to indicate that components, dashed line, and draw the horizontal line acceleration of the slider, or where it intersects. This is your required point, join these two. So this is your radial component of acceleration, this is tangential component of acceleration of AB, and this is your A prime, this is AB. So to calculate the angular acceleration, this is required, and by measurement, A tangential component of acceleration, and you know you want to calculate angular acceleration of AB, and this is nothing but your A tangential AB divided by the length of AB, that is 0.6, and this comes to, it is This value is 148 you are going to get, 148 meters per second square. And here you have to adapt a scale. Here for acceleration diagram, you take a scale for acceleration diagram. Here I am writing it as 1:20. 1 unit is 20 meters per second square. The scale for the acceleration diagram. With the scale you have completed. Here it is 1 unit is 1 meter per second, meters per second, and the scale for the configuration 1:5, 1:5, 1:1, 1:20. With this, you can calculate it is the answer is 173 radians per second square. Thank you.